If you look at this flight, you'll notice that the pilot does all sorts of circles and loop-de-loops and barrel rolls into the air, meaning that any rotating frame of reference it might have possessed prior to takeoff is now completely lost. The ground below would necessarily be spinning at high velocities towards the east. However, the airborne plane simply would not be fixed to that frame of reference without a ton of calculations and contrary acceleration eastward to find its way back to that frame of reference. It would be nearly impossible, actually. When you see the plane do a nosedive, one thing that you'll notice is the ground below is totally stationary, much like the observations made from high-altitude weather balloons. This alone proves that the world is stationary, as airplanes absolutely do not have any sort of instrumentation or Pilot 101 calculations that would need to be figured in order to return to the frame of reference identical to the ground beneath. In order for a plane to do a nosedive above a stationary Earth, the plane would need to do all sorts of calculations and maneuvers in order to return to that fixed frame of reference matching that of the ground below, just to attempt landing the plane upon a stationary runway. Another set of controlled experiments that have been done multiple times involves lining up a cannon or an air rifle or really any sort of explosive projectile. Definitely don't try this sort of thing at home, but you can even do similar experiments with something that's not even dangerous at all. But anyway, so experiments have been done that involve lining up a cannon or an air rifle perfectly vertical. So you use a plumb line to make sure that the barrel is perfect. And on a still day, this has been done, multiple times under controlled conditions, and they even fired them all the cardinal directions, but including perfectly vertical. This is the one that really interested me. The ball would always fall within a couple of feet of the cannon that fired it, and in many cases it would land directly back into the barrel of the cannon that fired it. Now, the animation you're looking at here is obviously not to scale, and it's exaggerated in terms of speed, but it's to show a point. We know that physical law, if you were spinning an object, and again, it is going faster than sound at the equator, so that's a high velocity spin, regardless of how large the Earth is. That's a very fast motion. Now, if the cannonball within the barrel of the cannon is traveling, at the same speed as the ground before it's fired, I've said this before, but one of the laws of motion is an object in motion will maintain its velocity until enacted upon by some other force. And we can most certainly consider an explosion compressed in the barrel of a cannon or even in the barrel of a rifle. We can consider that some other force, absolutely, for sure. The other point to consider is the Coriolis effect. And again, that has to do with a rotating frame of reference, which is a lot different than a linear frame of reference. Of course, people argue that everything maintains its angular momentum forever. And that may be true if you're talking about tossing a ball into the air. But even if you do that from, say, the back of a pickup truck while it's moving 5 miles an hour, you'll certainly see that the ball will maintain its angular or forward momentum up to the point to where it reaches the pinnacle, and then it will just fall straight down to the ground without that forward momentum. If you toss the ball high enough, of course. And this has nothing to do with the wind. Send the truck at 5 miles an hour, so there's not going to be a whole lot of back pressure. But toss a tennis ball, say, as high as you can, or 10 feet into the air, as perfectly straight up as you can. Might take you a few tries, but if you throw that ball perfectly straight up, you'll see that it sort of, tags along with you on its way up. But then as soon as it equalizes in midair and then starts to head down, it's going to slip out of that forward momentum. Objects don't maintain their forward momentum forever. And so from your perspective in the moving truck, it's going to start going backwards, accelerating to a maximum of 5 miles an hour, according to you, because that's how fast you're going. So it's just a natural law of physics. And so that applies to the spinning Earth, and if you apply that to the spinning Earth, it disproves the spinning Earth. It shows that we're stationary. You can ask any artilleryman whether they, figure in the spin of the Earth when they fire artillery, and they'll look at you like you're crazy because they don't. When you fire artillery, you just figure in, the angle and how far you want it to go, and it'll go about that far, depending on topography and winds and stuff, but it'll go about that far in any direction. when in reality, regardless of winds, regardless of people arguing that the atmosphere keeps everything spinning at the same rate as the ground, is ridiculous because, of course, when you're at a higher elevation, if the Earth is a spinning globe, then you're going across a greater arc. You have to cover a greater distance just to stand still. So even if it continued traveling at the same speed as the ground, the more altitude you gain, the further and further you must go just to stand still relative to the ground, or to keep up with the ground and remain fixed to that, frame of reference in terms of a rotating velocity, which is impossible. And of course, the momentum that it has is only lent to it by the Earth. If a plane is propelling itself in the opposite direction as the spin, that wind would, it would definitely be one hell of a headwind, but the plane would be traveling at a higher relative speed to the ground when compared to an eastbound flight, just simply because that's how reality works. Objects traveling in opposite directions will have a higher relative speed, so therefore the flight from New York to LA would have to cover much less air time. It would have to fly less distance through the air to reach LA because they're racing towards each other, and that's regardless of how fast it is not spinning prior to takeoff. People who argue this point are just arguing for the globe and not thinking about it. The Coriolis effect clearly proves that objects or planes are objects, but objects that are fixed to a rotational frame of reference do not remain stuck to that rotational frame of reference if they're compelled in a direction contrary to that, axis of rotation. If they're not fixed to that rotating body any longer, they are not going to remain fixed to that rotational frame of reference, especially if you've got jet engines attached, and that's with the atmosphere spinning or not. But the simple fact is you don't see all westbound flights with massive, massive headwinds, and all eastbound flights don't get massive, massive tailwinds, always as a rule, which you'd have to see if the globe was spinning east and the atmosphere was sort of velcroed to the ground somehow, which really doesn't make any sense if you consider space as an infinite vacuum with nothing separating the atmosphere from this infinite vacuum but the mysterious, non-proven force of gravity. The heliocentric model really just falls apart under all scrutiny. It doesn't make any sense logically. And when you point to flights being identical in duration from these 2 points, east to west and west to east, when you point to experiments done involving firing cannons directly vertical into the sky and having the ball land directly into the barrel of the cannon that fired it, conclusively proves that the Earth isn't spinning. You can argue this, but if you try to support your argument with physical experiments, you're always going to lose, because the physical experiments we do here on the ground in reality in controlled conditions conclusively prove that the Earth is stationary. In order for a plane to do a nosedive above a stationary Earth, the plane would need to do all sorts of calculations and maneuvers in order to return to that fixed frame of reference matching that of the ground below, just to attempt landing the plane upon a stationary runway. The fact is, no matter how fast a plane travels east, west, north, or south, if the plane does a nosedive, the ground beneath will always be absolutely stationary every single time, no matter what. Now, in order for this to work on the spinning globe model, you would need to have instrumentation designed to help the pilot return to the eastward frame of reference as the runway, and pilots would need to do complex calculations every single time they land in order to return to that frame of reference matching that of the ground below. The argument entailing the flights retaining their eastward velocity regardless of the plane's velocity or altitude is so very ridiculous. I can't believe so many apparently intelligent people will maintain this totally illogical and disproven position. In terms of the eastbound flight, the same sort of argument applies. If the plane is traveling east with the ground prior to takeoff, for every second that it wastes energy ascending, banking, it would begin to slip out of that eastward frame of reference, and the race between the plane and the destination would begin. The simple fact is, the two flights are often identical in duration, which totally disproves the spinning Earth. Period. This doesn't have anything to do with the atmosphere spinning with the Earth either. So, when you explain this to a globe earther, they will scratch their head and assert that, well, since the atmosphere is spinning along with the face of the Earth, then that's what causes the planes to remain fixed to the frame of reference with the ground below. This is just as silly as the first argument against the flight times conundrum, to be honest. The first point against this argument is the higher in altitude you climb, the faster the atmosphere must travel to remain fixed with the ground below. So if the ground is traveling at 1,000 miles per hour near the equator, and the atmosphere near the ground is traveling at that same speed, we'll grant that for argument's sake, but the atmosphere at, say, 5 miles or 10 miles high would need to travel faster and faster east in order to retain its fixed position above the ground. This is because if the Earth is a globe spinning, when you gain altitude, you'd be traveling across a greater arc and would need to cover more space in the same amount of time to remain fixed above the ground below. High altitude flights would increase the apparent ground speed of westbound flights and would decrease the apparent ground speed of eastbound flights, further showing this argument is futile and pseudoscience. This is all besides the point because westbound flights do not experience constant headwinds matching the rate of the ground, nor do eastbound flights experience constant tailwinds matching the rate of the ground. Furthermore, what about the atmosphere, say 30 miles up into the air? We can view weather balloon footage that clearly shows the ground below as fixed and it's not a globe. So what is causing weather balloons to travel faster and faster eastward as altitude is gained? Look at the footage of Felix Baumgartner's high-altitude skydive at 130,000 feet, and you'll clearly see that the ground beneath him is stationary even at those high altitudes. In other words, if the atmosphere is velcroed to the rate of spin near the ground, there's no possible way to retain that frame of reference if it's that high up, since it would need to accelerate faster and faster east as altitude is gained to remain fixed above the ground below. We can clearly see the ground beneath is stationary, and he's not traveling at a high velocity, apparently west, which he necessarily would be doing if he went straight up from the spinning ground below. Even if he was traveling at the same speed as the ground below, the higher up in altitude he gets, he should start slipping further and further west, since he's apparently traveling across a greater arc. Furthermore, if the atmosphere is fixed above the ground many, many miles into the air, adjacent to the vacuum of outer space in the heliocentric model, what could possibly prevent the upper atmosphere from expanding to fill the infinite vacuum of space? You can't just say gravity and that solves it. You simply cannot have a body of gas adjacent to a vacuum without something separating the two. Now, I'm not saying there's a glass dome in the sky, but what I'm saying is that space is not an infinite vacuum. The fact that our atmosphere even exists disproves the globe-Earth heliocentric model, but even this is besides the point of the two flights. It's just another major reason why the heliocentric model is totally incorrect, and it shows how, regardless of altitude, the world isn't spinning, which it should be, even if the world was a spinning globe and the atmosphere is velcroed to the rotational frame of reference near the ground. That frame of reference, there's nothing to cause the atmosphere to spin faster and faster as altitude is gained to travel across a greater arc and remain fixed above the ground. The final point to debunk is the claim that the flights are not identical, and the eastbound flights are often faster than the westbound flights. Now, that may be true, however, that's exactly the opposite of what you'd expect if the Earth was spinning eastward, or Pilot 101 calculations that would need to be figured in order to return to the frame of reference identical to the ground beneath. In order for a plane to do a nosedive above a stationary Earth, the plane would need to do all sorts of high velocities towards the east. However, the airborne plane simply would not be fixed to that frame of reference without a ton of calculations and contrary acceleration eastward to find its way back to that frame of reference. It would be nearly impossible, actually. When you use calculations and maneuvers in order to return to that fixed frame of reference matching that of the ground below, just to attempt landing the plane upon a stationary runway. Another set of controlled experiments that have been done multiple times involves lining up a... If you look at this flight, you'll notice that the pilot does all sorts of circles and loop-de-loops and barrel rolls into the air, meaning that any rotating frame of reference it might have possessed prior to takeoff is now completely lost. The ground below would necessarily be spinning at... See the plane do a nosedive, one thing that you'll notice is the ground below is totally stationary, much like the observations made from high-altitude weather balloons. This alone proves that the world is stationary, as airplanes absolutely do not have any sort of instrumentation